Hello everyone, so welcome on back to 9.6 Solving Right Triangles Part 2. In this video, we're going to be talking about the angles of elevation and depression. Now, before we get started, we need to know what these angles are. So, both of these angles are made with the hypotenuse and the horizontal. Now, this word horizontal means left or right, the direction, or you might see this word as meaning sideways instead. All right, so to help us illustrate what these angles look like or where they occur, we're going to go ahead and we're going to quickly draw a picture. So here's the ground. Let's say that this is a sidewalk. Here's a person. They're kind of taking a walk right now. And then as they're taking a walk, they come upon this really big tree. Okay. Now in this tree, there is a cat. He's taking a nap. And let's say that the cat wakes up. When the cat wakes up and if he sees the human, they can make eye contact. And that line right there is basically them making eye contact. Now, from this line, I can draw a vertical line. So from the cat, I can draw a line straight down and then draw the line over towards the human and connect it to make a right triangle. So now in the triangle, I have a hypotenuse. Here it is. I also have a line that is sideways or goes from left to right. This is the horizontal. And so the angle of elevation or depression that we're talking about is made with the horizontal and the hypotenuse. So the angle is actually right over here. So this angle that was formed right here is our angle of elevation. Now, why might this be the angle of elevation instead of the angle of depression? This has to do with the fact that the angle is made with the person on the ground. Now, they were originally walking straight forward, looking straight ahead. But when they saw the cat, they had to turn and look up towards the cat, and that formed a rotation. They rotated their head upwards to look at the cat. Hence the word or the angle of elevation, which means up or above. So the angle of depression is formed here instead. Now let's suppose that the cat, after he finishes looking at the human, he sees a bird. Okay. All right, so he's looking straight ahead at this bird, but the human can also look straight up and see the bird as well. So I can go ahead and draw a straight vertical line. Here is that right angle. And now I have formed another horizontal and another triangle. All right, and then because I now have a different horizontal, I can connect it with the hypotenuse here, and the angle that is formed on this side is the angle of depression. Okay, so technically two different angles, but if you remember from our parallel lines, these two angles are actually alternate interior angles. So what we can also say is that the angle of elevation is actually equal or congruent to the angle of depression. Okay, so which one you use, it doesn't really matter because at the end of the day, they are actually the same measurement. Now, my recommendation is that you draw the triangle on the bottom. Typically, it's a little bit easier to spot the angle of elevation than it is to spot the angle of depression. So if you draw in the triangle with the horizontal closer to the ground, Then where that horizontal and hypotenuse meet, that they make an angle, and that is our angle of elevation. All right, so let's go ahead and let's take a look at example 3 and look at how we will use these two angles to help us solve. Now, in the problem, it says that Rapunzel is looking down at Flynn with an angle of depression of 52 degrees. If Rapunzel's window is 50 feet above the ground, how far is Flynn from the base of the tower? Round to the nearest tenths. Okay, so the first thing we need to do is to draw a picture to help us visualize and see what the triangle looks like. Now, Rapunzel and Flynn are definitely not standing at the same level. Flynn is probably down here on the ground somewhere, and Rapunzel is up in her tower. So she's kind of far above Flynn. Here we go. There's a tower, and there's Rapunzel. Okay. All right, so when they look at each other and when they make eye contact, there is a diagonal. And then from the top of this diagonal, I can drop a line straight down and draw it across, connect to Flynn, and here is my right triangle. Now from the problem, we can pick out some important pieces to help us label the triangle. It says that Rapunzel is looking down at Flynn with an angle of depression of 52 degrees. Now, keep in mind what I said earlier. The angle of elevation and the angle of depression are made with the hypotenuse and the horizontal. So here is that horizontal side. Keep in mind that the one that's over here where Rapunzel is and the tower is, this is a vertical side. So I have a horizontal, I have a hypotenuse. So this angle here is the angle that we are going to label with 52 degrees. All right, continuing on with the problem, it says that Rapunzel's window is 50 feet above the ground. Now, we have to decide which two of these leftover sides, or rather 3 sides, apologies, represents 50 feet above the ground. Now, the key word here is above. Above meaning up or on top of. In that direction, when we go up, that is a vertical direction. So we're going to go ahead and label this side of the triangle with 50 feet. Okay. Now, last but not least, the question is asking how far is Flynn from the base of the tower? Now, that word base means the bottom. So it's not going to be the distance between Flynn and Rapunzel. It's going to be the distance between Flynn and the bottom or the base of the tower. So the line that represents that distance is actually the horizontal. So let's go ahead and let's call that X. Now, what I'm going to do is I'm going to quickly redraw our triangle so that it's a little bit easier to see and so that we can get some labeling inside. Here's the right angle. This side over here is 50 feet. The angle of depression or elevation is 52 degrees here. And the side that we're solving for is X. Now, to solve this problem or solve this triangle for X, we need to use a trig ratio. Which trig ratio all depends on which 2 sides we are given and which sides we are solving for. Now, we need to go ahead and label our triangle, of course. Here's the hypotenuse. The side across from the angle 52 degrees is going to be the opposite leg. So that's 50 feet. And then last but not least, the side that is labeled with X is going to be the adjacent leg. I'm given 50 feet. I need to solve for the adjacent leg. So out of all of our trig ratios, SO, CA, and TOA, the one that we're going to use here is TOA, because TOA uses the opposite and the adjacent legs. So writing this down, we have tangent of 52 degrees is equal to the opposite leg, which is 50 feet, divided by X. All right, and then as we are solving, or rather to solve this, keep in mind that we are not going to use the inverse trig here. we only use the inverse trig if we are solving for the angle. In other words, if it's a tangent of some variable, some letter. But because this is already tangent of 52 degrees, I don't need to do anything with it. What I need to actually do instead is multiply on both sides by the denominator. In this particular case, that denominator is x. So what we get is x times tangent of 52 degrees is equal to 50. Now, because this says x times tangent of 52 degrees, to finish up this problem, I need to divide by tangent of 52 degrees on both sides. So, tangent of 52 degrees on the left side cancel out. X is now equal to 50 divided by tangent of 52 degrees. Let's go ahead and let's put that into a calculator. All right, so it says it says 50 divided by tangent of 52. And then we, of course, want to round off to the nearest tenths. So that's what we get in our calculator after putting it in. We get 39.0, but we need to look at the 6 to see if we need to round up or down. And because this number is a 6, the 0 needs to become a 1. So our final answer for this particular problem is that x is about 39 1/10 of a foot. All right, so go ahead and pause the video here and see if you can give this one a try on your own. All right, so go ahead and double check over your answers. Here is that picture. There's a person flying a kite, and it's, of course, connected by a string, and the length of this string is what we're trying to solve. So my x is actually the hypotenuse this time. It says that the kite is 17 meters off of the ground. In other words, the kite is actually 17 meters above the ground. So that's why 17 meters is going to be this vertical side, okay? After labeling the triangle, we know that we're working with the opposite and hypotenuse. The only ratio that has opposite and hypotenuse together is sine. Substituting everything in, we finish solving and we get that x is approximately 18 9/10 of a meter. All right, so that's it for part 2 of 9.6, Solving Right Triangles. Thank you very much for watching.